So in Unit 6 and 930, we are going to talk about and explore everything there is to do with polynomials. In this first part, we've split into three different parts. So in this first part, we're really going to focus on just what is a polynomial, how to do operations with polynomials, and kind of get just the feeling of what those are. Then in part 2, we'll learn how to solve when we have polynomials, and part 3, we'll learn how to graph with polynomials. So just getting the basics down, and in our first lesson here of this first part, we're just going to talk about vocabulary. So what the heck is a polynomial and all those different kinds? So the most basic kind of polynomial is called a monomial. So a monomial is the first place that we're going to start. And a monomial is an expression that is a number, a variable, or a product of a number and one or more variables. Now, that's a lot of words, and I'm sure that some of that doesn't quite make sense, but let's think about it again. Okay, it's an expression that is a number, a variable, or a product of a number and one or more variables. Okay, so it could be a single number. So over here I have some space for some examples. So an example would be if I just had a plain old number like 12. Oops, here we go, 12. That's a monomial. I could have just a variable, y. That's a monomial. Or I could have a product, so a number and a variable, one or more variables multiplied together, right? So it could be 5x, y. That would be a monomial. But it could get more complicated than that, right? I could have, let's say, z to the 4th power. Anything with an exponent is still just a variable. That's a monomial. I could have, let's see, like -4 x squared y to the 3rd, right? That's a product of a number and one or more variables. I could have 1/2 z. That's a number and a variable, right? So those are all examples of monomials. Notice there's no pluses or minuses here. If it's going to be a monomial, everything needs to be attached with multiplication, all right? So those are all excellent examples of monomials. Now, the only kind of special one up here is the 12, right? That's just a plain old number. We don't always think of that as a polynomial, or in this case, a monomial. And since it's kind of special, we call that a constant, right? There's no variables involved. It's just a plain old number. If you look at the other ones, if I had values for x, y, z, that would change the value of that monomial. But in this case, that monomial will be constantly 12. There is no way to change the value of that monomial, which is why we call it a constant. Now, that's just some random vocabulary. It's not a super big deal that you remember that one is called a constant, but it might come up here and there. It's good math vocabulary to have, but the big idea is that you understand what a monomial is, and that's that one term, right? Where if it's a number, a variable, or a combination when they're combined by multiplication. All right, so the next thing that is going to come into play here quite a bit in this unit is the degree, okay? We're going to talk about the degree of a polynomial, and in this case, we're going to talk about the degree of a monomial, all right? So degree is a big one here. The degree of a monomial is the sum of the exponents of its variables. Okay, so there's some big key words here. It's the sum of the exponents of its variables. Okay, so only the exponents of the variables will count towards its degree, and if there is more than one variable, you have to add up the exponents. So here's an example, and we're going to kind of start small and get bigger. So our first one would be, let's say that I have just the monomial x squared. The degree of that monomial would be 2, right? I'm going to write that out, degree 2, because its exponent is just a 2, and that's it. And that exponent is on a variable. Okay, let's say that I have the monomial 8m to the third n to the first. So in this case, I would take the 3 and the 1 and I would add them up, and I would get 4. So I'm adding my exponents on my variables, right? All right, so let's say that I have negative 7xy squared. Okay, now be careful, right? Technically, I have the 2 here, but I also have this invisible number after the x, right? So that invisible number is the 1. So in this case, the degree would be 3. So don't forget about the invisible ones. But you only put that invisible one on the variables. Notice I didn't put that invisible exponent on the 8 on the previous problem or the 7 on this one, right? So it's just the sum of the exponents of its variables. All right, I got one more that's kind of tricky for you. What about the monomial 54? Ooh, tricky. That's a constant, right? There are no variables. So the degree in this case would actually be 0. You can kind of think of it like, see, there are no variables, right? Which means that exponent, the sum of the exponents, there's none of them. There's 0 of them, right? So the degree is 0. You can also think of it as if I had a variable there, my exponent would be 0 because there's none of them that was canceled out, right? So if there are no variables, we call that a degree of 0. If the variable's there, but no exponent written, that's a degree of 1, right? That invisible one if the variable is actually there, like the x in that last one, okay? All right, so that's the big idea of monomials. Just a number, a variable, or a combination, right, using multiplication. And the degree is the sum of the exponents of the variables. All right, now we could get more complicated, right? That's just what if I have a monomial. So now what if I have this thing called a polynomial? Now, as you can see, a monomial, that prefix mono means 1, right? It's all one thing attached with multiplication. So a polynomial, poly means many, right? So this is, a polynomial is the sum or difference of 2 or more monomials. Okay, so I'm going to take 2 or more monomials and I'm going to connect them together with adding or subtracting. So if you want to see an example, right, sometimes the example is worth 1,000 words. So if I had, say, 4x squared plus 8 minus 5y, that's a polynomial. Notice I have more than one monomial going on, and they're attached by pluses or minuses. That's when I call it a polynomial. Now, technically, a monomial is a polynomial, but we kind of separate them just a little bit. When we're talking about a polynomial, you know, like 2 or more monomials, in this case, many times you would, rather than refer to those individual parts as monomials, we refer to them as terms, right? I'm sure you've heard that before, right? When you think of combining like terms, you're looking at that whole expression and looking for the things that are the same. Well, those are what you're looking at is a polynomial and trying to simplify the polynomial a little bit. All right, so that was one example of a polynomial. I could have just two terms, 7x plus 4. That's a polynomial, right? That one has two different terms. I could have something huge, negative 3x squared y minus 4x to the third y to the third plus 8x minus 6. Those are all polynomials, right? And that last one, let's see, I have 1, 2, 3, 4 terms separated by those pluses or minuses, right? So there's my pluses or minuses. That means here's 1, 2, 3, 4 terms in that polynomial. Now that will come into play quite a bit coming up here in just a little bit. So just making sure you understand kind of the idea of what a polynomial is when you connect more than two or more of those terms using pluses or minuses. Okay. So a monomial was just a one term, right? And the degree of that monomial was the sum of the exponents of its variables, right? So the degree of a polynomial is the highest of the degrees of its monomial terms. So basically, you would find the degree of each one of its terms, and then the highest one of those is the degree of the whole polynomial. So it is the highest of the degrees of its monomial terms. Okay, and remember the degree of a monomial is the sum of the exponents of its variables. So here's just a little bit of practice then. I'll start with a more basic one. So practice here would be, let's say I have 4x squared minus 6x to the 7th plus 5. Polynomial, right? 3 terms. So what I do is I look through those and I look for I look for the degree of each of its terms, right? Okay, so the degree of that first term would be 2. The degree of the second term would be 7. The degree of the third term would technically be 0, right? Because there's no variable there, so that would be like x to the 0 power. So what's the highest of those degrees? 7. So the degree of the polynomial is 7. Okay, now if I kick it up a notch here, and I actually get more complicated in my terms, let's say I have 9 m to the 5th n to the 8th minus 4 m squared n squared plus 5 m to the 3rd n to the 4th. Oh boy, right? And if I wanted to find the degree of this one, I go through and I look at each of its monomial parts. So here I have to add my exponents, right? And my exponents of my variables. So 5 plus 8 would give me 13. Here I'd have to add these two exponents. I would get a degree of 4 on that term. Here I have to add these exponents. I would get a degree of 7 on that term. And then I look for the highest of those degrees, right? The highest degree in this case was 13. So the degree of my polynomial is 13. Okay? So a degree of a monomial is just the sum of the exponents of its variables. The degree of a polynomial, when you have more than one term, then you find the degree of each one of its terms, and it's the highest one of those. That's the degree of the polynomial. All right, so the last little bit of vocabulary then for polynomials is when we talk about standard form. So standard form for a polynomial is when you list it in order from highest degree to lowest. Okay, so the standard form is the order of its monomial terms decrease, from left to right. I should say, not really the order of it. I mean, standard form is the order that it goes in, but it's the degree of its monomial terms decreases from left to right, meaning it goes from highest on the left, highest degree, to lowest degree on the right. That's standard form, okay? Now it does seem, again, like the words are a little bit confusing, but the big idea here is the degree decrease from left to right. So highest on the left, lowest on the right. So if you look back at my examples, I was not always writing in standard form, and it's because I wanted to talk about it here. So for example, if we started with 6x squared plus 7 minus 9x to the fourth. That is not in standard form. Standard form would be take this biggest degree, right, x to the fourth, that's the highest degree, that negative 9x to the fourth would have to come first. And then after that, I would have my x to the second plus 6x squared, and finally my plus 7 that would have a degree of 0. So that same polynomial written in standard form would be negative 9x to the fourth plus 6x squared plus 7. And it's really important, we know that we can change the order whenever we're adding and subtracting, as long as we watch those negatives when we're subtracting, right? We can change the order whenever we're adding. So technically it's not a different polynomial, but it's just because these things get so complicated to write, it's just really important that you always write things in standard form for your answers so that it's easier for you to check your answers, it's easier for me to check your answers. It's definitely easier to put things into ClassKick or Edulastic because otherwise there'd be just a million possibilities for your answers. So we'll just make sure that when you write your answers, you're writing them in order from biggest degree down to smallest. And we'll practice that every single day along the way. Okay? All right, so here's just a little practice for you. Just to make sure that you can really pick out the number of terms, right? Finding the degree. And then this middle section, the name. We're going to talk about that in a minute, okay? But let's see if you can't just pause your videos, fill in the number of terms for each of these examples, and then the degree right now. So in that first one, 3x squared, there's no pluses or minuses. That's all one term, so that would be a monomial, right? And we actually know the name of that one because that's something we discussed. So this is a monomial. We said the degree of that monomial would be 2. Hopefully that one came easy to you. Here, again, no pluses or minuses. So that one is, again, one term. That one is a monomial. And since I don't have any variables on that one, technically we could also call that a constant. But if you called it a monomial, that's perfectly fine. And the degree on that constant, remember, there are no variables, or I would have x to the 0 power if I put in a variable. So my degree there is 0. And we did talk about that earlier. Okay, here again, no pluses or minuses, so that is a one term, so that would also be a monomial. What's the degree on that one? Now this one is a variable, so it does have an exponent of that invisible 1 there. So this has a degree of 1. So hopefully, again, just noticing the difference between this one and the last one. When is that degree 0, and when is that degree 1? And hopefully those two examples help clear that up if you were a little confused about that. Okay, now this one, I see a plus or minus there, right? So that means this has 2 terms. 6x to the third is one term, 5x squared y squared is the second term. So this has 2 terms. Now, technically, this is a polynomial, right? All of these are polynomials. However, one-term polynomial, we call it monomial. Mono means 1. Do you know the prefix for 2? This is called a binomial. When it has 2 terms, it's called a binomial. Bi, like bicycle. Bicycle has 2 wheels, right? So this is a binomial is when it has two terms. And you do need to know these names. These are going to come up a lot. So make sure that you know the names of these based on the number of terms. All right, so now if I find the degree of this first term is 3. The degree of the second term, I have to add those up and I would get 4. So the degree of my polynomial is 4 because that's the biggest. Okay, let's look at this one now. I see 2 plus signs here, which means I have 3 terms, right? 3 to the 5th, 2n squared, 8n. 3 terms. Do you know the prefix for 3? Yeah, trinomial on this one, right? Tri means 3. Tricycle has 3 wheels. So a trinomial is when I have 3 terms. Could probably put it back up here. Monomial, 1 term. We kind of defined that already though, right? Okay. Now, tricky one on this, the degree. The degree of my, let's say, okay, my middle term here, that one's easy, that's 2. My last one is a degree of 1, right? It's invisible. Be careful though. This is not a degree of 5 because that is not a variable. We'd have to say, what is 3 to the 5th power? Oh boy, I don't even think I know that one. 3 times 3 is 9, times 3 is 27, times 3 is 81. Let's see, 81 times 3, 243. So when it says 3 to the 5th, it's actually just the number 243. And there are no variables, so that degree is 0, right? So the highest exponent of variables is actually 2. So the degree of this polynomial is 2. Now that was super tricky. So just remember, I just wanted to make sure that you recognize that it's only the degree, the exponents of the variables. They won't usually be that tricky for you, but I wanted to make sure you were super clear on it. Okay, this last one, let's see, I have a minus, a plus, and a minus. That means that I am looking at 1, 2, 3, 4 terms on this one, right? Now you might be racking your brain trying to think of what the prefix for 4 would be, maybe quad, but not all the time. So actually whenever we get 4 or more terms, if they get bigger than 3, we just call them all polynomials. They don't have a special name anymore. So 4 or more terms is just a polynomial. And this one's not quite so tricky. So if I look at here, see, all right, that first term has a degree of 3, second is 2, third is 1, fourth is technically 0, right? So my degree highest there is 3. And notice those were in order, which means this one was actually written in standard form. And do you see how much easier it is to read it, to recognize the degree, all of that good stuff when it's written in standard form, and that's why it's so important that we do. Okay, so that table was some good practice, but it also helped us recognize these different names. So these names are all based on the number of terms. So 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial. After that, we call all the other ones polynomials. So you can kind of think of the word polynomial as like a big umbrella. And under the umbrella of polynomial, we have monomials, binomials, trinomials, and polynomials. And all the others, right? Okay, so we got through, that's basically it. Other than that, it's just practice. So just remember a monomial is a single number, a single variable, or a product of numbers and variables, means they're attached by multiplication. The degree of a monomial is the sum of the exponents of its variables. A polynomial is when you add or subtract 2 or more monomials together, right? More than two or more terms, then we start calling them polynomials. The degree of a polynomial is the highest degree of any one of its monomial terms. And then the highest of its monomial terms decreases from left to right when we write things in standard form. So just put that highest degree first, lowest degree last. That's when we call it standard form. All right, that was a good intro to polynomials.